Hello. The purpose of this short video is to illustrate two examples of binomials squared using algebra tiles. This is a series, one in a series of several videos using algebra tiles and then area model for multiplication of binomials. So here we go. We already have the first example, x plus 3 squared. And I already set it up like we did in the previous section, x plus 3 multiplied by x plus 3, because that's what this means. X plus 3 multiplied by itself. That's the square. And we're going to do this product, and we're going to do another example. And the purpose of this is to see couple of very interesting patterns. So let's do the product like we've done before, row by row. And let's fill it in, x squared, and then x multiplied by 3 is going to be 3x. And here, x plus 3 multiplied by 1 is going to be x plus 3, a number multiplied by itself. And that's the product. That is the squared of this binomial. X plus 3 times x plus 3 is very much the same logic we did before, but I want you to observe a number of things that are very interesting. Just like before, we have the x squared term on the top left, and now the square of 3, which is 9, on the bottom right, just like before. But I also want you to notice this. The like terms, 3x and 3x, are the same because we have a square. Previous examples, we built rectangles. Excuse me. Here, we are building a square. This square, which is x squared plus 6x plus 9, has a special name. These type of trinomials are called perfect trinomials. So this is a perfect trinomial. This x squared plus 6x plus 9. And all it means is that this trinomial came from squaring a binomial. X squared plus 6x plus 9. Notice the structure. Number one, it's a square. Number two, the x squared top left, the 9 bottom right, but the like terms are the same, 3x and 3x. Let's see example 2. Here we have an example where we have x minus 2 squared, and it's already set up in our area to figure out the product, the squared, and the same like we did before. X multiplied by itself is x squared. This time x multiply, I'm going to hide this, multiply by -1 is going to be negative. A number multiplied by -1 is the same value, but with the opposite sign. And we're going to have 2 of those. So that's the first row. And then I'm going to multiply these -1 by x, which is going to change the sign. So I'm going to get, when I multiply -1 times x, I'm going to get a negative x. And I'm going to take it here and place it like this. I hope you can see -1 times x is negative x. And then I have negative multiplied by negative, which is going to be positive. So this is going to be -1 times -1 is +1. I need 2 of those. And the next row is going to be identical to this one because it is the same product. So all I'm going to do is copy it, and there it is. So take a look again at the structure of these squared. X squared, top left, 4, bottom right, and the like terms are in the diagonal, but notice that they are also the same. It doesn't matter that the number is negative. We have -2 here and -2 here. These duplicate. They duplicated, and so our final expansion, our perfect trinomial in this case is x squared minus 4x plus 4. Notice too that the 4, this last term that I'm going to mark in blue here, is positive because a negative times a negative is a positive number. And here is also positive because a positive multiplied by a positive gives us a positive. So the third term, when we have a binomial squared, will always be positive. No matter if we have a positive here or if we have a negative here. Because when we multiply a number by itself, no matter what sign it has, the outcome is positive. And the other portion that is again critical is for you to notice that the like terms are the same, negative 2x and negative 2x for negative 4x. And that's it. We're going to go to area models without the tiles for our next portion. Thanks for joining.